Okay, in order to use the product rule for radicals to find the product, what you do is you just keep the radical like it is. So these are both square roots. So you keep it as a square root, and then you multiply the inside, so 3 times 5. So you get the square root of 15 is the answer to that one. On the next one, the same thing. You keep the index. This little number in the crooked part is the index. You keep that as the cubed root. You'll multiply the inside. 7 times 4. So I get the cubed root of 28. It's the same thing with the fractions, except on these I'm going to go ahead. Actually, I'm going to leave them all as 1. 3 times 5. That's a times. And x times y. So I get the square root of 15 over xy. The next one, what I want to do is I want to go ahead and split them up. So I split it up, and the reason I know that is because of the quotient rule. So I'm going to split it up, the square root of 5 over the square root of 36. Now there is no square root of 5, it's not perfect, so I just leave it as a square root of 5. Square root of 36 is 6. So the square root of 5 over 6 is the answer to that one. On the next one, I write it as the fourth root of x cubed over the fourth root of 16. Well, I'm going to see if the fourth root of 16, 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the fourth root of 16 is 2. So on the top, there's nothing I can do with that. The fourth root of 16 is 2. So that's going to be the answer for that one. Okay, number 16. Sorry, number 6. The cubed root of 5n over the cubed root of 81m to the 12th. Okay, let me show you something here. Since this is cubed root, I'm going to make a list of cubes. So 1 cubed is 1. 2 cubed, that's 2 times 2 times 2 is 8. 3 cubed is 27. 4 cubed is 64. And 5 cubed is 125. So I know that the 5 will not simplify because there's not a 5 on this list and there's nothing that I can divide into 5. So the numerator is going to stay like it is. The top part's going to stay like it is. And on the bottom, now 27, 81 is not on the list. So then you look for the biggest number that you can divide into it. 81 divided by 27 is 3. So let me come over here and do that. 81 divided by 27 equals 3. When you do that, when one of these divide out evenly into the number that you're looking for, what that means is the number you get when you divide goes inside your radical, like this. And then we were using the 27. The number out front of the entire thing, in other words, the number that has the exponent goes in front, like that. So that's going to be 3 times the cubed root. I'm going to leave a little bit of space here. I'll talk about that in a minute. 3 times the cubed root of 3. Now for my letter, for my m to the 12th, you divide. So 12 divided by 3 is 4. So I can actually, I didn't leave myself enough space. Let me go ahead and Start over again with that. Okay, so I've got 3 times the cubed root of 3, and for my m's, 12 divided by 3 is 4, so I can take those outside. So this is the answer to that one. Okay, number 7, simplify by factoring. Since this is a square root, I'm going to make a list of squares. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36, and those are the only ones I need because the number is 28, so I've already gone past that. Okay, again, what I want to do is see if the 28 is on this list, and it is not. So then I want to ask myself, well, can I divide any of those numbers into 28? And 28 divided by 4 is 7. So I'll go ahead and do that. 28 divided by 4 is 7. The answer that you get when you divide goes inside your radical. So this is the square root of 7. And the answer with the exponent, the number with the exponent is a 2 that goes outside. So that one is 2 times the square root of 7. Number 8, I kind of want to split these up like this. The square root of 4 and the square root of x to the 9th. Now the square root of 4 is 2. Remember, if it's a square root, so it's assumed to be a 2 in there, and that helps you when you divide, all right? Because 2 goes into 9 4 times with 1 left over. The leftovers go underneath the radical. You keep your radical just like it is. So 2x to the 4th times the square root of x is the answer to that one. This next one you literally divide. So for my f's, 10 divided by 5 is 2. And for the g's, well, 5 goes into 9 1 time with 4 left over, and you have to keep the index like it is. So f squared g, you don't need the 1 there actually. So f squared g times the 5th root of g to the 4th is the answer to that one. Okay, the next one, the 5th root of 50. Well, since it's the 5th root, let me make a list of 5s. 1 to the 5th power is 1. 2 to the 5th power is 32. 3 to the 5th power is 243. So obviously 50 is not on that list, and I can't divide any of these numbers into 50. So that means that 50 is going to stay underneath in my answer because I can't take it out. Okay, for my x's, 5 goes into 22 4 times with 2 left over. So that's the answer to that one. Okay, on the next one, the negative on the outside stays on the outside. So that is going to be a negative 448. Okay, what I can do is I can go back up to the squares here. I need to take it up to 100. Let me go ahead and do that. Okay, so squares. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. Once you make this list on your paper, just keep it because you're going to be using it over and over again. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. Now I know that 448 is not a perfect square, so I'm going to see if any of these numbers will divide into 48. 448, you start with the largest one. So 448, I know 100 won't work. 448 divided by 81, no, that's a decimal. 448 divided by 64, 64 and 7. Okay, so you can do that one. This one works. Okay, so what we have here is we have 448 divided by 64 equals 7. So that goes, and I'm going to leave some space here to put my letters and stuff. So that goes underneath. Whatever you get when you divide goes underneath. So the square root of 7. Whatever's in front of my exponent that worked goes out front. So that's a negative 8 out front. Okay, so for my x's, remember this is assumed to be a 2 in here. 2 goes into 8 4 times. And for the y's, 2 goes into 19 9 times. No, I'm sorry. 2 goes into 19 4 times. I'm not thinking today. 2 does go into 19 9 times with 1 left over. Because 2 times 9 is 18, and this is a 19, so that's 1 left over. So negative 8x to the 4th, y to the 9th, and then the square root of 7y. That's all your answer for that one. Okay, on the next one, here's what I'd check. I see if 36 can divide into 6. So 36 divided by 6 is 6. So I write that as the square root of 6, and then I'm done. So always check, even if they've got the radicals, the fractions split apart, always check and see if that divides out evenly. Because if it does, you've got your answer. So on the next one, on the next one, 48 divided by 3. Again, I'm taking the numbers under the radical and dividing them. So 48 divided by 3 is 16. So I can rewrite this as 7 times the 4th root of 16. Now let me see, the 4th root of 16, 1 to the 4th power is 1. 2 to the 4th power, 2 times 2 is 4, times 2 is 8, times 2 is 16. Alright, so that's actually got a value of 2. Because if the number underneath is on your list, then the number in front of your exponent is your answer. So that's going to be 7 times 2. So the final answer for that one is 14. Okay, on the next one, what I do is kind of like what I did with the numbers. I go ahead and divide it out, but when you're dividing with exponents, you're actually subtracting. So for this one, I have for my x's, I have 11, take away 1 is 10. And for my y's, I have 5, take away 1 is 4. And then because this is a square root, I could say 2 goes into 10 5 times, so that's x to the 5th, and 2 goes into 4 2 times, so that's y squared, and that one's finished. Okay, on the next one, I have my 2 out front. I have the cubed root. Okay, 32 divided by 4 is 8, and for my m's, 10m take away 1 is 9. Okay, the cubed root of 8. Well, 1 cubed is 1, and 2 cubed is 8. So 8 is a perfect cube, and the answer to it is what's in front of your exponent, which is a 2. So I already had the 2 in my original problem, and now I'm going to take the 2 out because the cubed root of 8 is 2. And then for my m, 3 goes into 9 3 times. So my final answer is 4m cubed. The next one requires a formula that you'll have to memorize. It's the distance formula. It's the square root of x minus x squared plus y minus y squared. Now you will save yourself a lot of time if you don't think of this as a minus sign, if you think of this as being the opposite. Because a lot of people make mistakes with the signs, and that will prevent that from happening for you. So these are alphabetical order. Now I know that the equation that they have you memorize in the textbooks is x2 minus x1 squared plus y2 minus y1. There's no reason to have the second one in front of the first one because it's squared. It all works out the same anyway. So what I'm going to do for this is I'm going to go ahead and plug everything in. So I have my x, and then the opposite of positive 19 is negative 19, and I square that, plus my y value is 4, and the opposite of positive 9 is negative 9, and I square that. So that's the square root of negative 12 squared plus negative 5 squared, which is the square root. Negative 12 times negative 12 is 144, plus negative 5 times negative 5 is 25, which is the square root of 169, which is 13. The next one, the same thing, xy, xy, the square root of x, negative 2, and then this one, the opposite of negative 2 is, the opposite of positive 2 is negative 2, and I square it. Plus, for my y's, I've got a 4, and the opposite of negative 3 is positive 3, and I square that. So then I get the square root of negative 4 squared plus 7 squared. So that's the square root of 16 plus 49, which is the square root of 65, and that one cannot be simplified. So that's your answer.